Welcome back, noobs and pros. You are listening to Kubernetes Notes and I am Funny Chidala. In this episode, we will discuss the worker node along with the networking challenges and the possible Kubernetes configurations which you need to know. Let's get started. A worker node provides a running environment for client applications. Through containerized microservices, these applications are encapsulated within pods, and these pods are controlled by the cluster control plane agents which are running on the master node. Pods are scheduled on the worker nodes where they will find the required compute, memory and storage resources to run and networking to talk to each other and the outside world. A pod is the smallest scheduling unit within Kubernetes. It's a logical collection of one or more containers scheduled together. Now let's talk about the components present inside a worker node, starting with the container runtime. Although Kubernetes is described as a container orchestration engine, it does not have the capability to directly handle containers. In order to run and manage a container's lifecycle, Kubernetes requires a container runtime like Docker to be installed on the worker node. The episode will continue after this short message. If you like our work and would like to support us, you can visit buymeacoffee.com/Chintu. That is buymeacoffee.com/CHINTU. Now back to the episode. The next component is Kubelet. Kubelet is an agent running on each node, and it communicates with the control plane components from the master node. It receives pod definitions primarily from the API server and interacts with the container runtime on the node to run containers associated with the pod. It also monitors the health of the pod's running containers. Kubelet connects to the container runtime using CRI, which stands for Container Runtime Interface. CRI implements two services: image service and runtime service. Image service is responsible for the image related operations, while the runtime service is responsible for all the pod and container related operations. And then there is kubeproxy, which is a network agent running on each node, responsible for dynamic updates and maintenance of all networking rules on the node. It abstracts the details of pods networking and forwards connection requests to the pods. There are certain add-ons which are cluster features and functionalities not yet available within Kubernetes, therefore implemented through third-party pods and services. For example, DNS, dashboard, monitoring and logging. Now that we've seen the components inside a worker node, let's talk about the networking challenges which need to be solved if you want to run an application properly inside Kubernetes cluster. Now that you have decoupled a monolithic architecture into microservices, which are decoupled, these heavily rely on networking with each other in order to mimic the tight coupling once available in the monolithic era. Networking in general is not easiest to understand and implement. Kubernetes is no exception. As a containerized microservice orchestrator, it needs to address 4 distinct network challenges: container-to-container communication inside pods, pod-to-pod communication on the same node and across cluster nodes, pod to service communication within the same namespace and across cluster namespaces, and external to service communication for clients to access the applications inside the cluster. All these networking challenges must be addressed before deploying a Kubernetes cluster. Now let's see the different configurations in which Kubernetes can be installed. The 4 major installation types include all-in-one single node installation, where there's just one node, master, worker, everything is in the same thing, same node. The second configuration is a single node etcd, single master, and multi-worker installation. The third configuration is single node etcd, multi-master, and multi-worker installation. And finally, multi-node etcd, multi-master, and multi-worker installation. With this, we have reached the end of the episode. Once again, thank you very much for listening to us. I am Fanny Shizela. I'll see you in the next episode.
If you like this episode, please consider following us wherever you hear your podcasts.